Welcome to the Memetune program, Series 3, Episode 2. Coming up today. Switched On enters the ARP Temple, taking a close look at the Chroma Polysynth. In Synthesizer Club, it's Desert Island Sequential Circuits, Little Black Boxes, features the boring looking Korg M3R. Patching today is on the mighty EMU Modular again. And in Video Lab, I connect everything up wrong, or do I? Here's Switched On. The ARP 2500, the legendary concert grand of synthesizers. Some say it was the pinnacle of modular synthesizer design. Spectacular looks, complete versatility, but above all, the majestic power of its sound. For almost 10 years, ARP Instruments sailed high on the crest of an analog waveform. But like most of its American contemporaries, towards the end of the decade, it struggled to stay afloat in an ever-saturated and watered-down market. In an attempt to revive their fortunes, in 1979, the design team came up with one last highly ambitious project to create the ultimate polysynth, a radical hybrid of analog sound and digital microchip control. The result was the ARP Chroma. Unfortunately, it was a disaster, because ARP went bust before it was finished. But all was not lost. The company behind the Fender Rhodes electric piano stepped in and took the project on, retaining the entire ARP development team. And the Rhodes Chroma rose phoenix-like from the ashes of ARP in the year of 1982. Let's head over to the Memetune Synthesizer Center to find out more about this epic polysynth. The Chroma is an example of what I would call a second-generation polysynth, as it blended analog sound generation with digital control. This was quite uncommon for the late 1970s and was supposed to be its unique selling point. If the Chroma had been released as intended in 1979, It would have led the pack in terms of cutting-edge digital features. But the all-digital Yamaha DX7 came out in 1983, and it killed off all the analog polysynths.
Get ready.
Inside the chroma, the Motorola 6809 takes care of all the patching and memorizing of settings, and because of this digital functionality, the panel here can operate in two modes. The first is as a preset selector, and the second puts it into programming mode. Sound programming is carried out by selecting a parameter with the buttons on the panel, which are divided into the various functions. You then change the values with the data slider. The chroma voice structure also operates in two modes: 16-channel polyphonic or 8-channel, which you change by pressing the patch button. To get inside the chroma's head, you need to consult the cheat sheet, which was part of the user manual and explains all the hidden features. These include the initial voice algorithm on the left here, and then along the top there are all the available modulation sources. Along the bottom are the modulation destinations. In single mode, you can play 16 notes polyphonically, with each note having roughly these building blocks. In paired mode, you have 8 voices of polyphony, but the voicing options are doubled to yield the following facilities per voice. Depending on how the initial patch is set up, this is where things can get very experimental, like on a modular synth, because you can keep patching things together until usually you crash the system. Here's some more demos. The Memetune Program Annual 2023.
4.
Joining the club today, Sequential Circuits.
Today we have a relatively simple patch. All you need is one of these. The beauty of the EMU is that it has extremely nice sounding building blocks. The VCOs are rich and powerful, and the filters are some of the best ever designed. But like a lot of early 1970s systems, there's something about the way the amplifiers work that has a big impact on its character. For example, when you overdrive one of the VCAs, it distorts the oscillator waveform in the most pleasing way. So today, I'm using the VCA before the filter to exploit this interesting characteristic. Let's begin. First, I'll connect the waveform output mixer of the VCO to the input of a VCA. The VCA then goes to the resonant filter, which will be our main output going to the mixing desk. Next, I'll take the clock output and send it to a multiple, as it will be used to run the whole patch, starting by triggering the envelope, which in turn shapes the VCA to produce the notes. To change the pitch of the VCO, I'll use 2 rows of the 8-stage sequencer, which I'll combine to provide a 16-note sequence. This is not straightforward on the EMU. I need to use a module called the analog switch to take the 2 sets of CVs from the sequencer and switch between them to give us 16 notes. This module does not have its own sequential switching built in, so I have to use another module called the triple latch to do it. The latch works like this. A trigger at the clock input will set the output to a positive state where it remains until another clock arrives. It then goes negative until the next pulse, and this has its own output. These 2 states can be used to turn on and off other modules, in this case the analog switch. The switch has up to 4 inputs, which are summed at the output and can be turned on and off. I'm using 2 of them here to combine the 2 8-step sequencer patterns into one pattern of 16 steps. The CVs will go to a quantizer to keep the notes fixed to 12-tone intervals. Now I want to do something extra to make the melody develop a bit more. I want to transpose it automatically. To do this, I'll use the fixed CV switching module, which provides 4 fixed voltages that you can tune to offset the sequencer voltages by combining them at the VCO input. The 4 voltages can be turned on and off with triggers. I'll use the ModCan sequencer to do this, as it's sitting right next to the EMU. The pulse from stage 4 of the 8-stage EMU sequencer will go to a clock divider so that it moves the ModCan sequencer along every 16 notes. Then it will send out the various triggers to the EMU fixed CV switch. In total, it will now generate a sequence of 144 notes before it repeats. The last part of the patch is to send the filter two slowly moving LFOs to move the cutoff frequency around a bit. And that's today's patch. Note that the final mix has a tiny amount of delay on it. Today in the video lab, I'm deliberately connecting things up the wrong way, which is where the fun really starts with this old video gear. All of the visuals in this episode are going to be made with nothing plugged in to the video mixers at all. On this Panasonic production mixer, which I extensively overviewed in the previous episode, you can connect its ins and outs together round the back. Then, you can use the big lever to control the amount of feedback you get. I'm pretty sure this feature was not intended by the designers, but to me it's one of the most interesting aspects of these kinds of devices. By using the scene grabber and the joystick, you can start to play around with the light and colour and movement. Next, if we add a second unit, you can increase the complexity of the video images quite considerably. Now I'm going to add in the Grass Valley Indigo mixer, which was made a few decades later and is digital. It has some more features, of course, such as true picture-in-picture and 3D effects, but it is essentially the same as the Panasonic's in concept.
Well, that's it for the Memetune programme, Series 3, Episode 2. Thanks for viewing.